Video I am going to give the demo for the loan approval prediction and some of the useful insights. Okay, first let's see what is loan approval prediction. Whenever the customer, the public needs the loan from the bank, they go to the bank via portal or they can visit the branch and they can apply for the loan. Once they submitted the loan approval, the bank has to evaluate the credit worthiness of the customer by some certain logic has been there at the bank side. They can evaluate the credit worthiness of the customer and they can provide that they can approve the loan or they can reject the loan. In full stack application, we must to have some front end, back end, and the decision engine. The decision engine is nothing but a set of rules. When I say set of rules, basically it contains a set of if-else statement that has to satisfied to fulfill to for the loan approval. The bank has to rely heavily on the decision engine. So in the modern tech stacks, we have a data-driven insights. Using the machine language, we should be able to do the prediction for the loan approval with the machine learning program itself. That's the advantage of this program. First, let me quickly show how the program is working. This I developed so far with the backend only. I don't have a front end. Okay, since we don't have a front end, I keyed in all the input in my Jupyter notebook file itself. And then here I have the data. The sample data I already trained and tested the data. The data set I got it from the Gaggle. So here this is just you can assume that this is the data we get it from the customer, or this is the data we can give it as an input in the Jupyter notebook file itself. So this one we are getting it from the user, and the loan prediction, the algorithm basically runs determined based on the training set and the test set and the evaluation set. It's predicting whether the loan can be approved or not. Here you can see whether the loan is approved for the first customer and the second customer. Okay, let's go to the next slide. Okay, so this is the problem statement. So this one, it's modern way of giving the solution with the data-driven insight using the machine learning approach. This is the fastest way to get to evaluate the credit worthiness. Okay, next we have the data snapshot. Here I have the various features. So I categorized into four categories. One is demographics, financial, credit profile, and property information. Some of the features or column names are gender, married, dependents, education, applicant income, co-applicant income, loan amount, credit history, property area. So here we can say that some of them are numerical, some of them are categorical. So as you know that machine learning can do their best with the numerical data only. So we do a one-hot encoding. Using that, we convert the categorical columns into some meaningful way. Like we reduce all the we reduce all the categorical column and have it as a true or false kind of thing. With that, we can feed the futures column into our machine learning program, and we can evaluate the credit worthiness of the customer. So here you can see the approval rate. The approval rate for the given data set from the Gaggle which we got, approval percentage is 69 and rejection percentage is 31. In the next slide, so this is the solution summary. I covered all of these phases in detail in my previous video. So just this is the overview about how I solved the problem. So first I did the data collection. Next thing I did the cleaning. So here you can see that we do have few missing loan amount, credit history, self-employed fields are the missing columns. So in the cleaning, we used the various pre-processing technique to complete the pre-processing. And once the cleaning process is completed, we did the explanatory data analysis. We did univariate and bivariant analysis, and then model training. Before I did the model training, I did the standard scalar and then did the model training. And then once the model is finalized, I did the hypertuning parameter and then went to the deployment status. Here I used tool stacks such as Python, Pandas, Scikit, Matplotlib, Papermill, Joclip. These are the tools I have used in my program. So the output is the trained model prediction with the 80% accuracy. We got it. So exploratory insights. Here I did univariant analysis and the bivariant analysis. The univariant analysis, first I'd make sure that the data is very clean, and then I assess how many categorical columns are there, how many are numerical, that kind of analysis too. And the numerical features, I need to scale, do the standard scaling, make sure that the machine learning algorithm doesn't confused with the higher value amount. Okay. And next is bivariant analysis. In the bivariant analysis, I did the analysis about which column contributes more to the model performance, means which column gives more significant for the model performance. Okay, the credit history is the strongest predictor, and the numerical column incomes, loan amount terms as doesn't have much significant relationship with the loan approval. And we do see married and the education column, that is also doesn't have weak relationship, only doesn't have strong relationship. Next one is the semi or the property area. The customer who lives in which place got the more approval rate. So the customer who lives in the semi-urban regions has a higher chance for the approval. In the rural area, the loan approval percentage is 61. Next one is the model training. First, we started with the basic modeling, machine learning algorithm. I evaluated with 6 to 7 algorithms. Out of that, the logistic regression model performed well. That has accuracy of 86 and the F1 score of 90. Once I finalized the model, I did the grid search too, and the accuracy has been increased after that one. Okay. Next one is the implementation. Okay. If you wanted to install this program in your machine, you can download this from the GitHub repository. And then once you can activate the Python virtual environment, and I do have the README file, you can refer that one. I have the data collection, which is basically for collecting the data set, pre-processing. This is for doing the pre-processing steps, and EDA univariant bivariate Jupyter notebook. This one is to get the business insight. Next one is the feature selection. Here I did which feature contributes, can be ignored, which feature contribute more towards the model performance. Next one is the model baseline and evaluation. Here I ran all the machine learning programs and evaluated the accuracy and assessed the F1 and accuracy score. So next one is the final model. So before we do the final model, here I did the hypertune the parameter, and the percentage got increased after the hypertuning the parameter. Next one is the model deployment. I tested the functionality with the sample input in the Jupyter notebook itself. So the CLI option, I do have a run notebook.python file. So this one, with this, you can run all the programs sequentially. You don't need to, if you wanted to run the Jupyter notebook individually, you can do that one. Or if you wanted to run all the files in a single shot, you can go and run the run notebooks.python file. Next one is the project structure. Here you can see the repository structure. Here I have kept all the Python file under the source folder, and all the notebook files under the notebook folder. And I do have the CSV file in the data package. I do have the loan data set. And next one is the artifacts. Here I stored all the model hypertuning parameter and which model performed well in the pickle file. Okay, and the data set I got it from the Google. That's it. I already showed the demo as well. Hope you like my product. Thank you.